Okay, so in this video, we're going to go over the area of a circular sector, okay? So first off, let's look at the diagram over here. We've got a sector of a circle, looks like a piece of pie here. The radius r is going to be part of our formula. The central angle theta is part of our formula, and the total area of this piece of pie here, or this sector of this circle, can be found using this formula, okay? So the area of the sector of a circle is going to be 1/2 times the radius squared times the central angle again, which has to be in radians, okay? We just went over the arc length of a circle, and our central angle always has to be in radians for these formulas, okay? So think about that. If you're given a central angle in degrees, then you're going to have to convert that first, all right? So let's look at example 4 here. We want to find the area of a sector of a circle with a central angle of 60 degrees, okay, which is pretty close to this angle here, if the radius of the circle is 3 meters long. Okay, so this radius would be 3 meters here. All right, so like we said before, we're in degree here, so the first thing I'm going to have to do is convert 60 degrees to radians. And remember, when you convert degrees to radians, you're going to multiply by pi over 180, okay? And when we simplify that, 60 degrees times pi over 180 simplifies to pi over 3 radians. All right, so this will be what I plug in to theta for my formula here, okay? So let's find the area of this sector of the circle. So area is going to be 1/2 times r squared times theta. Plug in the values we know, okay? So the radius is 3 meters, and again, I'm going to keep the units in my formula here. Area should always be a length to the second power for units, like feet squared, meters squared, centimeters squared, etc., okay? So when I square 3 meters here, that's going to square the 3 and square the units. So just be aware of that. Okay, so, and we plugged in pi over 3 for theta. Okay, so when we do the math, 3 squared is 9, okay, which would be in the numerator. So the numerator's got 1 times 9 times pi, and the denominator just has 2 times 3, which is 6, okay? So the area is going to be 9 pi over 6 meters squared. Now, I can simplify that, so my exact answer needs to be simplified. So 9 pi over 6 simplifies to 3 pi over 2 meters squared. If you're looking for an exact answer, this is exact. If you need an approximate answer, which might have a little more meaning to you, go ahead and use a calculator, and 3 pi over 2 is approximately 4.71, okay? So the area of this sector right here would be 4.71, approximately 4.71 meters squared, okay? Now, just like in the arc length video you just watched, you can solve for any of these variables. So I'm going to do one more example where we solve for the central angle theta, okay? So let's look at example 5. A sector of a circle of radius 24 miles has an area of 288 miles squared, okay? And we want to find the central angle. And our answer when we're finished should be in radians. All right, so we've got our formula. Let's plug in what we know. So 288 miles squared equals 1/2 times 24 miles, which needs to be squared times theta, okay? Now, when I square 24 miles, I get 576 miles squared, okay? And then when I take half of that 576, I get 288, okay? So 288 miles squared equals 288 miles squared times theta. So I'm going to divide both sides by 288 miles squared to get theta alone, and 288 miles squared divided by itself is 1. So theta, the central angle here, has a measure of 1 radian, okay? So that's how you use this formula to find either the area of a sector of a circle or to find the central angle that's being cut by that sector, okay? You could also solve for r if you needed to. I'm not putting that in the video here, but if you have any questions, please reach out and let me know.